बोलो। हाँ, थोड़ा बिजी रहेगा अभी मैं, कुछ होगा तो मैसेज करो। नहीं, ठीक है, मैं बाद में बात करता हूँ।
Hello, sir.
Yeah.
Sir, Priyanshi this side. I have been talking to you. I am the chief officer for PR, and we have our host who will first introduce you, and after that you can start your lecture. Is it fine?
Yeah, it's okay with me.
Sir, we'll be starting in 2 minutes then.
No problem. I'm available. Try coffee.
Good evening to all our viewers. Greetings from CESA VJTI. I hope everyone, the viewers, the CESA team, our today's guest, all are well and healthy. I am Riddhi Vimple from second year BTech Civil Department, and it is my pleasure and an honor to host this event today. Welcome to the first guest lecture of our prestigious the STHAPATYA Guest Lecture Series 2022. VJTI was established in the year 1887 and is upholding its proud legacy of over a century filled with brilliance and educational prowess. Furthermore, it has thrived in nurturing the brightest minds of the society. Civil Engineering Students Association, CESA, is a departmental students committee and has been organizing various lectures, conducting various events, and carrying out projects since 2017. STHAPATYA is an annual technical fest hosted by Department of Civil Engineering VJTI, held under the aegis of the Civil Engineering Society. We organize various events related to the field of civil engineering to gauge students' ability to apply foundations of civil engineering into practice. STHAPATYA has achieved huge success in the field of engineering and corporate sector. Talking about STHAPATYA 2021, we decided to take it one step further and make it an international level event. And our monumental efforts got through flying colors with virtual participation of 1,200 people, which included both national and international professionals of civil engineering field. We were successful in our events from top universities of India like IITs and NITs, and from international universities of Canada, South Africa, etc. Every year, CESA VJTI invites guest speakers who are well known in their fields and industry veterans to come and interact with students and lecture them to bridge gaps between theoretical and practical knowledge. In past, we had Shri Jayant Patil, Minister of Water Resources of Maharashtra, Priyanka Gupta, the founder of Reservoir Constructions, and many others who have graced CESA with their presence by progressively illuminating young minds to new areas of civil engineering interests. Today, CESA VJTI is honored to have Mr. Subrata Dutta. Welcome, sir. Sir is the project director of world's largest stadium, the Narendra Modi Stadium. Mr. Dutta has over 30 years of experience of project management in the construction industry. He has played an important role in construction of few high-rise buildings, 5-star hotel, mega convention and exhibition center, and lot of precast works of heavy elements. He has been featured in National Geographic in Megastructure Program slot for construction of Twin Tower, Atmosphere, a luxury residential superstructure in Kolkata. So, we are looking forward to explore your journey that would surely inspire us. So without any further ado, let's be a part of the conversation by paying all ears to Sir's words. Sir, passing it on to you now.
Thank you, dear student, very much. And I am overwhelmed to be with you all through this virtual mode. It's my privilege. I am privileged to be here to present my case. I have a 30-year experience, little bit brief, my dear student, presented to you all. So civil engineering is the father of engineering, mother of engineering, and the most old engineering. Without civil engineering and civil engineering excellence, society cannot be run, development cannot be happened. So now, cut short, it's a very good opportunity for me also to present me and my project. So I come to the direct subject. So my screen, I think it is visible to everybody, my PPT. It's okay?
Yes, sir.
I'm audible also?
Yes, sir, you're audible.
Yeah. So Narendra Modi Cricket Stadium, this is one view. You can see, follow my cursor. This is the main stadium. Other than that, there are two practice field, one training center, multi-purpose sports hall, this is, and some other training center, running track, this football ground, hockey ground. And there is one structure, the way you can see my cursor, this is the clubhouse. So this is the old stadium, and you might have heard of it, last 1000th one-day ODI match. It has been played there 2 days back with the West Indies. This stadium, actually there is an old stadium near me here, the same similar location, the same location you can say. Its capacity was less, it has been demolished, and the area clear and give it to us after we winning the contract. If you see the aerial view area, so other side, where my cursor you see this habitat area, people are staying here, buildings are there. Other side also staying are there. There is one structure, this is one Hanuman Temple. This is our old temple. Without disturbing this temple, we have done our design and construction. This is the main stadium. This is the area for the people walking and other thing. And this is the area, this is one ramp is there. Another ramp is there. These are all views. I'll give you the detail in succeeding slides. And if there is one small building you might have seen here, for better answer, Y shape. So this is a little bit clubhouse-like arrangement for both the field. When people are playing, they can occupy this area. When this ground will be available, they occupy this area. So that's the way it has been designed and built. Now, project brief. I'll go with this flow of my presentation. The project brief. So, client is Gujarat Cricket Association. It's a design and build contract. Architect for Larsen and Toubro Construction, Building and Factories Division. Our PMC was Stoop Consultant Private Limited. Concept design Populous. Populous, they are mainly from Australia. They have done the Melbourne Stadium planning and detailing. So basic design by them. Detailed designing, detailing, everything done by L&T, our own design team. Total plot area you see 63 acres and a built-up area 17.32 lakh square feet. So I'll follow this unique feature of the stadium, site logistic plan. It is based on mainly precast, so precast erection. There are some roof structure here, structural steel, resource planning, quality, field of play lighting, because this is the only cricket stadium in India, the periphery ring of this stadium where my cursor is moving. There it put the all Philips light, LED light, continuous into the ring for this field of play, and some awards and accolades what we received during the construction after also. So unique feature, what is unique feature? World largest stadium with 1.1 lakh spectators. It has our contractual obligation. We have done it. But after that, client has reviewed everything and established it is not 1.1. We can accommodate 1.32. And that was the media they have presented to all. There are 76 corporate boxes. So every stadium, you know, there is a VIP area, players pavilion, rest, other facilities area. Mostly VIP pavilion, one pavilion, where 76 corporate boxes are there. Other than that, one international standard swimming pool. We can say Olympic standard swimming pool. This is this small one bluish structure you can say in my cursor. So I think this is that swimming pool. Over 8,000 numbers of precast element, more than 8,000 number precast element we have used in this construction. Heaviest column was 285 metric ton. What we have erected with a single crane, it's a Y-shaped column. And definitely LED light features for the field of play lighting. If we'll see the master plan, we have divided the area like that. Suppose 1 and 2. So 1 and 2. So this is all the pedestrian entry and pedestrian path towards the stadium. 3 podium. This 3 podium means it is the whole concourse surrounding the stadium, so which can take the crowds. People come directly to this podium. From there, they can go in the upper bowl and lower bowl. Total stadium divided into 2 bowls, 2 sitting area. One is called upper bowl, one is called lower bowl. 4 is the field of play. The 11 pitches are there, the main stadium. 5, VIP building. In stadium, this portion, there was a VIP building which accommodated 2-level VIP and other boxes, corporate boxes, other facilities, gym, players area, their offices and everything. Then 7, you can see earlier actually there are 3 ground, but in this new stadium they are using 8 and 7 as a practice field. 9 number practice field, what is earlier converted into a multi-purpose sports complex. And main substation, because this is the 10th number, this is the area where substation is there. It is mainly for DG, AC, chiller, panels and all other supply line. You can say STP, everything is there in this location. So this is the overall, distribution of all systems, details of area allocation within the stadium area. So now the construction, how we'll proceed with the construction? Because this is a precast area, precast construction. That means overall this elliptical side, if you can see, there is elliptical shape. It's not a circle. So we distribute in various zones, zone 1, 2, 3, 4, 5, 6, 7, 8, like that. There are some expansion joint. Mainly zone division is the expansion joint of the precast. And according to this area, we can independently do our erection and construction sequence so that we can use in any multiple work front. So this is the most important in project management part. So when we are doing the precast methodology, it's the only two reasons. One is the quality and another is the time, project time. It reduces huge time, project time, if we do the precast. And definitely, as it is a precast, quality is definitely very high, very under control, and easily achievable. So that way we distribute the area and progressing with the job. Zone 1 is a VIP, but this particular structure is a cast in situ. Other all structures here is the precast. So now the main thing is the methodology of precast system, how we have developed the precast system and how we follow. That the next slide I'll explain you. See now this slide, it is in November 2017. You can see the photographs of the site. What you'll see, this is the VIP building cast in situ is under progress. Stadium bowl is just, we have started foundations, other things. See, this is the foundations that we have started. Few erection we have done, Y column. That was the status. Now February 2020, stadium complete and everybody aware of it. Trump, then President of America, USA, visited and have a program with Mr. Narendra Modi. So it is hardly 3 years and 4 months our effort, support from GCS to everybody, all stakeholders, and we reach in this status of the stadium, this stage of the stadium, final stage. Now, if you'll see how the bowl and other structure is demarcated. See, this is the lower bowl. What is required? It is a record element they are telling, because the sitting arrangement we called as a record element. Upper bowl, double L-type bleacher, some element names are mentioned. I will explain it differently. This is the VIP pavilion I told you, explain you, the cast in situ. Most of the structure is cast in situ. Only the sitting arrangement, what you are seeing here, it is precast. So 2 corporate box, and there are below that there is a big hall for the dining and others, and below that there is a players area, and in front of 2 locations there are some sitting arrangement, 1, 2, 3 layer sitting arrangement. Each and every stage people can see the matches from inside corporate box. If they want, they can come out and see the match also from the outside. And this is the other area where the precast erection has been done. See, I have told you main column is a Y-shaped column. I can show you, and that's the podium area for the people. See this column, it is looking Y-shaped. That is the column configuration. So now this is the one section of the stadium, major stadium sitting area. See, this is the upper bowl and this is the lower bowl. Is the various dimension is there. what 44.6 meter for the lower bowel, then 41 meter Y column to Y column distance. But you can see the major column backside. This is my cursor is moving. It's a V column like that, Y column you can say, and this is the another column. So what is the column height? 36 meter from this ground level. But column started from the starting from the foundation. So this full column 100% we make a single piece. This is the beauty of the project and part of special feature. So another column is Y column. This is 165 ton and this is that 200 plus 80 ton column. But this two column tied with a main beam. Circumferential beam is this, raker beam is this. In direction it is called raker beam, and this perimeter direction you can say circumference beam, and from there bleacher, upper bowel bleacher, that's the sitting elements has been erected. Similarly, lower bowel, this column, foundation and column, similarly there was a raker, beam, and that sitting arrangement, this is raker, beam and raker arrangement, which is mainly for the sittings of the people. And if you will see foundation, what is the type? Isolated footing and combined footing. Podium, precast beam, precast ribbed slab and hollow core slab we use. Lower bowl, cast in situ column. This column are cast in situ. Precast beam, raker and bleacher. Sitting arrangement is all are precast. Upper bowl, precast Y column, precast beam and bleachers. All are bleachers. All are precast. As the grid is H and G, we demarcate this column as HY and GY. This is on the section of the precast stadium. So now how to do erection, handling, that I'll show you. You can see this is a big crane of 500-600 ton we use. This is your strong back arrangement to hold the column and erect. Next slide I'll explain you. Now, as we have done the precast, definitely reinforcement cage is required before casting. So what we have done, we have made a separate bed. We have done this reinforcement cage separately, prefab cage like that, and with a big crane and different strong back arrangement, we lift the cage and place into the shutter before concreting. Aerial view you can see, this is the bed for the precast column. This is the bed for one big beam. This is the casted beam we have kept here. This is the casted column after demolding. This is the another Y column, smaller Y column, front side. That's the bed. And this is there. A casted element, we keep it. And this is the area where the casting has been done. And this is in between, there is approaches are there for crane movement, trailer placing, and everything. So that's why it is demarcated HY, GY, and PRB, primarily radial beam. So this is the name. So how will transport the big element like that? Self-propelled modular trailers. 3 sets of hydraulic axles with a combined capacity of 400 ton. So this trailer, there are 3 units. We place accordingly and keep the column on that with the dead load. These are all tied. You need not to tie separately with this. And this is the self-modular hydraulic axle, because we need not to operate like an engine like that. It's hydraulic operated with a control. We can move each and every wheel. Generally, big vessels and other thing can usually be done in this way. And turntable arrangement we use to negotiate with the accurate turns in the blaster mode. When there is a turning, because our approaches are little bit, stadium is elliptical, means this is not a straight road. this is a circular type road. So definitely during movement, trailer will be moved, turned. So that arrangement also taken care. So main lifting point was chosen just 2 feet above the center of gravity. So this is another point. If lifting point is above the gravity, so definitely element will be vertical. If we'll twist or if we turn out element horizontal to vertical, definitely we need to move the element. We need to rotate the element. So rotation then only possible when our anchoring point will be above CG. Due to CG, element try to take his own on gravity, it will be vertical. It will turn automatic and keep its position. So the special lifting arrangement into lifting clamp with turn union arrangement of ceiling, you can see that this is the arrangement. There is a big bolt is there with that arrangement. Otherwise, there is a little bit gap I have to provide between this member with the concrete. Otherwise, stress will come on the concrete. So that way it has been designed. I can show you one model here, which has been done in our design office. You see that for the lifting, how we'll do it. It's the only model. People understand the anchoring point. And see, this is the foundation like that, and they have done it. So now you can see the actual video at site. You can see it is time motion video. So how to tilt it. See below that there are some trailer. You can see from the trailer it has been lifted and tilted, and it will take the vertical position. Each and every column at the base, there are some slithing pipe are there, 30 to 32 numbers, because the foundation where it will anchor, you can see the projected rods are there, reinforcement of various dia. Generally 32 is the majorly dia, and this column will go in the position and insert into the sleeve. You can see people are placing reinforcement just that align in it so that easily it can go inside. Yeah. Top, you can see there are some holes are there. So this is the opening of the pipe from where grouting will be done. See, I can show you how grout filling direction from the top. This is the hole from where grout will be done. So see that. From the top, grout will go inside and slowly go up because the holes are there. So in this case, from the top will pouring grout. Benefit, there will be no air inside. Air locking not possible because as soon as it will go inside, the entire air will come up and it will be totally filled up. And in the bottom of the column, there is some V notch is there. So this is also take care of the key, connection key like arrangement. Maximum strength required release crane for GY and HI column 60 to 80 MPa, which is achieved in 20-26 hours respectively. Because HY, GY column, when you erected and grouting, that time crane is holding that. So after 20-26 hours, we can remove the crane with tie because that time grout strength will be sufficient to hold the column. So this is the lifting point chosen as per the CG and tilting angle because this is an inclined stadium configuration. So beam also to be placed inclined. So how the configuration, accordingly we handle the elements. And you can see lots of temporary tie you have used. This tie is required for the stability of the column which is just erected. You can see how it is. This is one big column. There are two beam like that. In between, temporary structure are there, column to column, beam to beam. There are lots of staging is there because to placing the beam, most of the joint is a cast in situ joint. Other thing, joint is mainly a cast in situ. And in between two beam, there is another cross beam. The central part is a precast and end portion is in situ. Means this beam also have done a precast, but both the end we leave reinforcement which is connected with the main beam. So the circumferential beam CB it is called. It is connected with the PRB, primary radial beam. This is the primary radial beam. And we make one very big structural cage like that so that beam can be placed before lifting. Labor can go inside fearlessly to do the job for connection. See, people are here, all safety nets or other thing is there. So people very fearlessly do the job at that height. And there are some stools are there we measuring and put so that beam can be placed on that, which finally match with the reinforcement with whom it will be connected. You can see the each and every element, how it is demarcated and what is their individual tonnage. PRB 2, 80 metric ton. PRB 1, 120 metric ton. HY column, 285 metric ton. Then another column, 120. Some circumferential radial beam, 22 ton. CB, 30 metric ton. So, different tonnage we handle with the crane. So this is the staircase, and this staircase are 7 elements. You see assemble of staircase with parapet wall and ground, 7 elements, and erection as a whole. So 7 elements casted separately, assembled at site, erection location, and from there lifted with the crane and erected. Again, there is a challenge. Challenge means whatever the logistic issues are there, means crane movement problem are there, BIP side, both the side, where we cannot do the precast, we have gone by through cast in situ. You can see the huge arrangement for the cast in situ. In cast in situ with 45 days cycle time is executed in few areas where accelerated cranes are not possible. Is 45 days also we achieved after 2-3 cycle. Where precasting only took 10 to 12 days from casting to erection. So this is the beauty of precast. At least 4.5 times less or 5 times less time required with no much risk. Risk means that much of vertical arrangement, lots of staging, people go up and they are concreting. And so that's why risk mitigation little bit easier, construction friendly, and definitely time saving. Now the precasting I discussed, you can see the all precast after erection, sitting area, it is complete. Then they have started client also for the chair fixing there. But another thing is that this stadium having a steel roof arrangement and PTFE membrane as a roof cover. So that also I explain something about the roof structure. See, this is the roof structure you can say above the precast, but it is no connection with the precast item. There are separate circular structural steel column is there, for their foundation is different and take whole load of compression ring of structural steel and this, because there will be a very big movement in the room, in this roof. This movement, due to this movement, no stress should be developed or transmit into the precast structure. That's the design criteria we follow here. So you can see one by one element we have erect. support with the temporary structure. Then from there, this is a cable stray arrangement. The cable is connected with this roof structure. There is a strand jack. With this, cable has been traced after layout, and then whole cable will pull up in the position, which is holding the total roof system, means PTFE membrane covering. So this is the roof cover. You can see it is from the cable. It is supported from cable only. So this is the live photos of steel column. There are some walking platform. People will go there to work. This is the temporary structure, because when the total ring will be erected and connected, then it will balance each other and it will be stable. Before that, we have to support with a temporary structure. See how the structure has been built and go up. You can see there is one small projection like that. It is the gutter. Because when there is a roof, some water will rain, then that rain will come into the gutter. So the gutter was assembled with the roof supporting structure and go up. There is the erection. So now, after completion, the whole ring has been erected. Everywhere there is a walking platform we have fixed, because people will go there and use the jack. It is compression ring erection with temporary platform for cable work. That cable laying, cable tracing, everything will be done from the platform. So this is one write-up. It is nothing like that. It's about the stadium. STHYAPATYA Stadium is owned by Gujarat Cricket Association, the underway zone. It is equipped with floodlights. Earlier days, the floodlights. Yeah, Test cricket and one-day cricket played. It's just a brief. In October 2015, stadium was demolished to allow for a big-scale renovation, and the revamped stadium has been planned to be like a Melbourne cricket stadium. That's I'm explaining you 63-acre land, 4076 corporate boxes, Olympic-size swimming pool, 4 dressing. This stadium has another feature. There are 4 dressing rooms, means 4 teams at a time accommodate in the stadium. So this is the another part. Stadium reconstruction project is estimated cost 7 billion. That time little bit less, more. And how much parking? 3,000 cars, 10,000 two-wheelers inside that. The clubhouse having 55 rooms. Initially 3 practice ground, but now 2 practice ground and 1 training facilities. You can see the tension ring erection, which is called a big lift, because all this cable has been laid into this platform. You can see my cursor. This platform, we laid this cable, and this connecting cable from where connected to the roof connector, when it has been pushed, jacking to be done, that time this cable started lifting from this level and go up to this level, the required level. This is called the big lift. Now, after the big lift I've done, we have put some platform here. This platform is required for the light arrangement. People, maintenance staff go for the light checking and that. At the same time, you can see there is a big truss-like arrangement who is handling the PTFE membrane for laying of the roof arrangement. To install this, people should go in the both end. So then again, another working platform has been erected. People will be both end. From there, they handle this cloth, or you can say the roof membrane. Now you can see how the membrane is being, then every membrane has been clamped. Every part that's connected with that, it has been clamped. And finally, this was the shape of the stadium while we have done roof sheeting. So it is from the top, this is the view, old view. You can see some web-like structure where my cursor is moving. This is the facade of a stadium, but this stadium is the bank of Sabarmati. So that's why its architecture view like a wave. It's give a wave of the river, that feel. Now, most important, field of play, subgrade drainage work. Because every stadium there is a field of play. And there is a rain. If rain has happened, match maybe sometime abandoned. But nowadays it is not happened. After rain, 15 minutes, 30 minutes, if it is rain, water will out, again match will start. And that is only possible through a proper planned drainage system. So if you can see, this is the drainage system we have done. Root zone area means where the grass, you can see the grass, below the grass, this root zone area, where the root will be, the grass will penetrate. Below that is a fine sand area. Below that 50 mm coarse gravel, then 100 gravel, then there is a trench. And that trench has been digged like a fishbone like structure. I'll show you the next slide, where the drainage pipe will be there. So when rain is there, this is percolated through this layer and collected in this pipe, and from this pipe it will go out in a ring main. From there it will connected in a drain, and that drain is exclusively for this field of play. No other connection with that drain. Now you see, this is the drainage arrangement. This is the main pipe, this is the subsidiary pipe, and this is one periphery, there is a drain. From where water will collect, go to the main drain, and from drain it will go out. And these are the sprinkler arrangement for the watering of grass. So I can show you sub-drainage technique, how we have done it. See, this is a machine for trenching like that. I have shown you the geotextile membrane, metal. Below that there is a pipe. So slowly it will cover. Then that metal pieces has been laid, gravel layer. Above that you see the sand is then. It is mainly the sand. So therefore people when they're playing, they dive and everything, they not take much impact on their body. Otherwise, this is dangerous for the player. And this is the field of play after sand filling. Now you see the round means this is the sprinkler. The sprinkler will wet the ground. And this is the pitch. Separately, pitch has been developed. And the field of play irrigation system, there are some sensor we have adopted. Sensor we have done it because mainly it has been planned to take the water from STP and irrigation purpose for using in the field of play. But there was we have done the digitization system methodology where it will assess the moisture content of the surface. Accordingly, water will be sprayed. So it is nothing but one conservation of water methodology. Next feature is the field of play light. That is so unique feature of the design is this. You can see in our ring there is a light. You can see this is in India, this stadium, Dubai Stadium, similar type of light. And here it is glare free. Some stadium you can see when player will play 4 shadow, 6 shadow. Here it is a complete 0 shadow. High wattage LED light fixtures we have done against conventional. Lower depreciation of lumen output, hence larger lifespan. Very low startup time. You might have observed when there is a tower-like structure, lighting structure, if something power off, if it on, it will take some time. Or it will slowly become yellow, then it will full. But in this case, very fast. Very low startup time. If it's off, immediately it can on, immediately. And it is a distributed ring arrangement against the conventional high mast. And because this near, high mast everywhere may not possible also. If there is nearby any airport, so that is very difficult for cross a certain height. So in that way, because you know the height of the light mast is more than the stadium. So here we mitigate that risk. Otherwise, it is very difficult nearby airport getting the airport authority clearance of the height. And it reduces the harsh shadows. Figure mounted on the roof, they blend in along with the structure. This improves aesthetic appeal. Definitely, no separate structure, nothing. It is blended with the inbuilt roof structure. So it is aesthetic appeal is much more. No observation, aviation clearance, what I have told you. Canopy shadow formation of the field of play avoided. It is not there. Reduction in number of electrical fixtures required for operation by mounting closer to the field of play. That also not required. And reducing the power consumption. As it is LED, definitely power consumption will be less. Earlier it is a metal allied versus LED. We know nowadays it is the thing. Now, what's the quality with speed? When speed is there, definitely people will ask how will maintain the quality. You can see grade in situ junction M50 special design concrete. What we achieve after 56 days, it is go up to the state 83.8. 28 days we receive 69. Why we do this? With this immediate demolding, immediate dehiring crane, removing structure support, it is possible. Means our process will more faster. Some best practices I can show. You can see there is one lower bowel sitting arrangement. We have make it temporarily. People are sit with a full 1:1 scale because people can see the ball properly at the near boundary, at the farthest boundary. So many stadiums you can see, you cannot, if player will dive near towards your boundary, you cannot see. You cannot see the proper ball, whether it cross the rope or not. So that we have designed and verify through this model. I think it is the first time in the cricket history, in stadium history. Other than sample room, because lots of finishing material we use, so many sample mock-up we have to do for the approval. There is a compound wall, there is a precast, and there is they create a logo, GCA, ball and 2 bat. Very fine, and everything is done in concrete. And this is, we have developed, L&T, our site team, proper rubber mold we have developed. And with this rubber mold, we have done this. Otherwise, there is a famous company, Erection. They are using the mold for this type of design pattern, but we have done it through rubber mold. Definitely, this type of structure, there are some execution challenges faced. Few of them I want to explain. Unexpectedly, fly ash bed below foundation encountered. Actually, earlier, it is the area for dumping fly ash of a power plant. After that, fly ash not been dumped, but it is crossed through a pipeline further away. But it is a long, years ago. It maybe started 70s, 80s, that time. So some earth will be there, some fly ash will be mixed up. We don't know what's happening. When you've done the site survey and our geotechnical investigation and the terrain, so some area we cannot find out the test through this. But when you go the excavation, nearby foundation, which is the deeper foundation, if you can see this, there are some foundation, but there are some deeper foundation. It is the level is different for this. So based on the design, some foundation take deep. So when we do this excavation, we find out below certain depth of soil is very good. After that, there is a loose fly ash. Already foundation done. What to be done? We have taken a cautious call, designing everything, the cement grouting. So we have done a cement grouting through this. So that total area became a hard strata with a cement, fly ash, other sand, everything. So that way, this is geotechnical engineering scheme we have done. and followed SBC verification also after that. So this is one challenge we face and we mitigate. Then I can show you there is some bearing. There are 4 bearing in the VIP because their span of support is more. So that is the bearing. But that bearing is a special type of bearing. The delivery time of the bearing was not matching with our erection sequence. What we'll do? We'll put some temporary structure, erect the full ring. After that, when bearing comes, we lift the bearing and we place the bearing below the ring. Whatever the concreting part we complete, then I connect the bearing with this ring, then we remove temporary structure. So this is the location, scheme drawing, how to do it, temporary support, ring support arrangement, lifting arrangement, how to lift the bearing there. You can see, then place it, then you will shuttering and concrete. And this is the concrete after shuttering and bearing connected. You can see the bearing connection done. Then we remove the temporary support. This is another problem we face. There is one Chetco line. It's a high voltage line overhead near to the stadium. Only one portion we have seen when I've done the erection, people feel some electrocution. Then we'll test lamp. With the test lamp, you can see when it touches the element, lamp is on. That means there is some induction current. So what we have done? We have earthed everything, each and every element, crane, everything. We have taken earthing and insulation. You see, concrete bucket, there is a put earthing. Crane, we have put earthing. Everything earth it and complete the job without any hazard or any accident or any difficulties to anybody. Some photos I want to show you. Most of the people who have seen the match, a better photo, better view, we can see. This is from the outside. This is very front of this because this is one practice area. People they want, player they want, they can practice here also. 2 teams can practice, 3 to 6 pitches are there. VIP, this is the VIP block elevation. You can see the sitting arrangement. So these are the rooms, individual rooms. From there, people will come out and sit. These are the rooms. People come out and sit. This is the clubhouse, swimming pool. This is clubhouse, shoot room, interior. This is a clubhouse, TV room. This is clubhouse, banquet room, interior. This is gymnasium from clubhouse. This is clubhouse, restaurant. VIP block team shower and toilet because every team needs some shower, toilet separately. This is the main VIP block, main lobby. This is the banquet. So this is the level, I think, this is the level where people can come during the match. Lots of fun arrangement shops are there for foods, other things, beverage. So people can go there outside and they can sit and enjoy the matches. This is chairman suite. So chairman suite exactly aligned with the center pitch. This is team briefing room before match, after match. Team may be briefed by the coach and other staff, support staff. This is the VIP podium area. I have shown you in that picture. This is the real photos. This is the white color you can see. The numbering has been done for the ticketing system. This is the locker room. Each and every player can keep their material here. And definitely the mechanical, electrical and plumbing works, how it is. Passenger lift, outside from inside. This is water cool chiller. There are a pump and other arrangement. This is cooling tower, electrical panels, and definitely FOP light and floodlight on comparison I have shown. Some awards we have received our project team. That is PY award, Process Improvement Award within the L&T. Sword of Honor of British Safety Council. It It is the highest honor in the safety, base safety project pan L&T construction. That time 18 million safe manhour certificate. And definitely we have done some digitization. You know, L&T as an organization driving digital initiatives to improve safety, quality and operations. There are lots of safety apps. So from mobile we can control, we can do some format, nothing required as a hard copy. ProCube, that is our progress monitoring tool. And finally, this is the team who make it possible. And with this, I can thank my team to be part with me in the construction and we safely handed over. Thank you.
Thank you, sir, for such an insightful lecture. The magic of precast which you talked about, the wavy feature relating to the Sabarmati banks over the stadium were the most fascinating things I heard. Also, the accommodation of 4 teams in a stadium is something which tells us the best about the project. I'm sure that I'm speaking on behalf of the entire audience watching us right now that you really inspired us with your groundbreaking thoughts as you were beginning on this journey and presented us with brilliant ideas while instilling a new perspective in our lives. So, I request you to answer some of the audience questions.
Sure.
Firstly, being project director of the world's largest stadium, what all difficulties did you face?
No, difficulties means lots of activities we have done here. So the activity sequencing, doing this, so that multiple activities can be going on at a time. At the same time, resource planning, movement of resources, because that area is very much restricted. You know, lots of crane you have used, 600 and 500 ton, 300, 200. So at a time, 3-4 crane may require for one operation, movement. So that's cycle time monitoring. And these are the main challenges for this type of project.
That was very inspiring and far-sighted for all of us here, sir. So for the next question we have, how's your experience working with India's premium infrastructure developer L&T?
Within a few months, I'll complete my 30 years in L&T.
So that's really great.
And definitely 30 years in one company means it's become my own heart. It's taken place. Lots of challenge. Those who are you are all are now doing civil engineering. Definitely you have been aspiration will be more. But nowadays I am telling people are not very much interested in that. Parent subject means civil. People go to IT, MBA, somewhere, some marketing. But challenge is there in civil engineering and groundwork. Lots of scope, lots of scope are there still. At my point.
That was very informative, sir. So moving on to the last question the audience has for you. What message would you like to give to the budding civil engineers?
Budding civil engineers is my first point. Whatever you are learning in the college, the basic thing, please keep it in your heart and mind. When you go to the project work, definitely you have to do people management, project management, but your own subject is technical thing. You cannot go beyond that. So technical knowledge, basic knowledge you need. I don't tell you have to design every time in that type of caliber, but at least basic knowledge is required. You carry that basic knowledge with you. People are there to groom you and shape you as per the requirement. So this is number one. Number two, you have to love this job. If you're in construction, it is not a 4, 5 or 8 hours job. There's lots of responsibility, lots of location issue-wise. You may not every time get a connectivity for mobile and that. Then you feel, okay, how should I do job this type of area? I can go and some different job. So that hardship, we have to, be ready for that initially. And mostly your sincerity So I think this 3-4 thing, if you can keep in your mind, you can sign as a civil engineer. That's not an issue.
Thank you, sir. That was really helpful. It was indeed an amazing session, sir. Knowing about the world's largest stadium. We are simply elated you could join us today as a part of CESA family. Also, thank you to our wonderful audience for tuning in. We hope you all really enjoyed this session. See you all tomorrow for the second session of the guest lecture series. Tomorrow, we'll be hosting Mr. Mukesh Rawal, statue in the world, which is the Statue of Unity. Do subscribe to CESA's YouTube channel. Don't forget to share. I'm Riddhi Pimple signing off. Take care and stay safe. This is CESA VJTI.
Thank you all.
Thank you, sir. That was a really great session. Knowing
It's a
about
good opportunity for
in
me
much detail.
to present myself. Thank you very much. Take care. Be safe. And do well, definitely.
Thank you, sir.
Welcome.
Thank you so much, sir.
Thank you, sir. Thank you, sir.
Thank you so much, sir.